A Stuart 10V steam engine rebuild. This is part 6, cleaning up the flywheel in the lathe and showing how I usually modify Stuart Pistons to take steam grade silicone O-rings. The episode starts by fitting the pinch bolt to the flywheel which holds it to the crankshaft. Personally, I would like this part of the job to be more substantial, but this is a sympathetic restoration and where possible I'm using the parts that were originally fitted. What I'm going to do is clean up this flywheel, and for that I need a mandrel in the lathe, and here it is. This piece of bar was turned to be the right size to fit in the hole in the flywheel, and because this piece of bar was actually turned in this lathe, it's very accurate. All I have to do is fit the flywheel to the mandrel, run the lathe at a medium fast speed, and use wet to dry sandpaper to start with, followed by Scotch-Brite to clean up the outside of the flywheel. The flywheel is wobbling a little bit, but this is due to the fact that it isn't a tight fit on the mandrel. It doesn't need to be. I'm only cleaning up the outside edge very gently. I wouldn't normally do this. I'm pressing the piece of wet to dry sandpaper against the outside edge of the flywheel. Normally I would fold it into a pad. My fingers are too close to the flywheel, hence the red cross at the beginning of this sequence. I purposely do not want to over-clean this flywheel. This is a sympathetic restoration and I do need to leave some of the original tool marks in it. As you've just seen, I finished off the job using a piece of Scotch-Brite. The original patina on the flywheel is preserved, it's just a lot cleaner. Now finished with the mandrel, I can remove it from the chuck. In this shot of the flywheel, as I move it around, you can see that the tool marks are still present on the outside of the rim. By the time I've finished this engine, all of the cast iron parts will look about the same. This is a good indication of what it's going to look like as you see the parts here on the bench. However, I did need to modify the piston considerably by machining a groove in it to allow the fitting of a steam grade silicone O-ring. I've done this many times, so here is a clip from a video I made in 2021 which shows the process. It's slightly different because I actually made new pistons and I've showed that sequence as well. Here are the original gunmetal pistons with oil grooves machined in them. I need to remove the pistons from the piston rods without doing any damage. This is the method that I normally use. In my small Myford lathe, I've clamped the piston in the chuck and then I clamp the piston rod in the tailstock chuck. I chose to rotate the tailstock chuck to unwind the shaft from the piston, but some viewers may wish to do it the other way round, hold the shaft firmly in the tailstock chuck and rotate the headstock chuck. Either way, the piston is separated from the piston rod. These pistons are supposed to be 1/4 inch thick and I'm just verifying this with my micrometer. I didn't really need to use the micrometer for this job, but just for certain viewers who like things to be right, I'm showing that it's not the right size. It's a few thou out. 4 thou to be exact. And this really doesn't matter. This is the piece of metal I'm going to use to make 2 new pistons. The original pistons are made from gunmetal. My pistons are going to be made from brass. And making pistons from brass is definitely not a good idea if you're going to have metal-to-metal contact, because brass wears out very quickly. But in this case, as I'm using O-rings, the actual piston will be undersize. How much undersize, you may be asking? Well, according to the internet, it says 1 thou per inch. In this clip, my micrometer tells me that the original gunmetal piston was exactly 3/4 inch, which is pretty good really. When these pistons were originally fitted into this engine, when it was fed with steam, the heat would have caused all the metal to expand, and gunmetal expands more than cast iron, which means that when the engine was in steam, the piston would have been a really snug fit in the cylinder, and the oil grooves would have held the oil, so everything was fine. After centre drilling the part, I'm drilling quite a long way down this piece of brass using a tapping size drill for 4BA. In this clip, you can clearly see the chunk out of the piece of brass where I didn't face it at the correct depth all the way along. You may also have noticed the depression left by the centre drill. The next part of the job is to carefully tap the hole in the centre using a 4BA tap. As a lubricant, I'm using WD-40. It works quite well when you're tapping brass, or aluminium, or any metal really. The next part of the job is to face across the front to remove this depression in the centre caused by the centre drill, and with a bit of luck it should remove the mark that are left on the front of the metal. Sometimes piston blanks are counter drilled to support the piston rod, but on this engine the pistons weren't made in this way. The shoulder on the piston rods are screwed firmly up against the piston. Time now to part off the first of the piston blanks. I'm using a ruler to set the position of the parting tool, and once this piston blank is parted off it will be slightly over the required finish size of 1/4 inch. All finish turning for both of these pistons will take place once they are mounted on the piston rods and not before. And here I'm screwing the piston rod into the piston blank. Now it's time to cut the groove. You need to be very careful when doing this because you've only got the thickness of the piston rod supporting the work. Sometimes you can actually centre drill the end of the piston rod and put a live centre in there, but on such a small engine all I have to do is be very gentle. In this part of the clip I'm using a needle file to remove any sharp edges. And that's it. I just need to remove the finished piston from the chuck, but before doing that I'm verifying that the groove is the correct width and depth. Next part of the job, fit the piston ring to the piston using plenty of oil and try it in the cylinder. And if it fits okay and slides up and down nice and easily, you've got it right. Here I've temporarily screwed the pistons into the crossheads, just so I can see them going up and down, for no other reason. I just love the poetry in motion of reciprocating engines. So there you have it, 2 pistons in a double 10V. I'm working on a single cylinder version of this engine, the Stuart 10V, and I chose to machine the existing piston for a silicone O-ring and not make new ones, but I could have done it either way. Here's a part where I drilled 2 holes in the top of the piston to screw it into the crosshead. I've drilled this hole in a piece of brass so I can pop the piston and rod into the piece of brass. Then all I need to do is hold the brass in my drilling machine, my small drilling machine. And here you can see what I'm going to do. The jig that I've made supports the piston whilst I drill it. This clip shows me using my deep hole marker to draw a line across the top of the piston, first on one of them and then on the other. This will allow me to rotate the piston in the drilling jig and drill 2 holes that are in line and equidistant from the centre. Maybe it's not the type of engineering that some viewers will be used to, but it's my type of engineering. And in no time at all, with the help of my calibrated eye, I drill 2 holes in each piston. I've set the drilling machine depth stop so it can't go all the way through. That wouldn't be good. Before fitting these pistons into the engine, I will be dismantling them, removing the O-rings, giving everything a thorough clean so there won't be any metal particles lurking about in the cylinder. It's very important to remove all traces of swarf and metal chippings from the piston before you fit it into the cylinder. I'll show that in the next episode, but that's it for now. Stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.